Example 3 from 2.4. We wanted to find the remaining 0 from given functions. And 3 minus 4i is a 0 of the functions. So again here, this is similar to the example from 2.3. You already have one solution. You need to find rest of the solutions. You have fourth power, right? You have highest exponents. The degree of function is 4. It means you're going to have 4 solutions. So this is going to be your first solutions. And you need to find 3 more. But whenever you have imaginary unit as the solutions, there will be another one just like that with opposite sign in between. So if this is given, then we know that not only 3 minus 4i is the solutions, but also 3 plus 4i is solution 2. Remember, because when you're using the synthetic divisions, you have minus b plus minus square root of b squared minus 4ac. So this plus minus sign right here, this gives you, if you have I solution with negative, then you have to have I solution with positive, because I have to be square root 1, right? So if you have a square root solutions, then plus minus signs of the solutions come with it. So 3 minus 4i is solution means 3 plus 4i is also solutions. So we already have 2 solutions. We need to find 4. We have 2. So let's see what happened. What other 2 solution we can find. In order to do that, I need to factor these 2 solutions out from the given functions. And we will do that by using synthetic divisions. So I'm going to copy 1, all the leading coefficients. Okay, let me use the black. So it'll be 1 from the 4th power, from the cube. So make sure this is cube, not 5th, right? Cube. So 1 from the 4th, negative 6, positive 28 from the square, and negative 18 and 75. And we're going to divide this with first 3 minus 4i. So your algebra is going to be a little longer, but you'll be able to get the quadratic out once you factor out this 2. So 3a minus 4i will be multiplied into 1. Then you get 3 minus 4i. And when you're adding, you can only add the like terms. So negative 6 plus 3 will be negative 3 minus 4i. And when you're multiplying 3i minus 4i times negative 3 minus 4i, let's see. I'm going to work on it on the side so you can see. You have 3 minus 4i times negative 3 minus 4i. You do FOIL. So that gives you negative 9. And outer will be negative 12i. Inner will be positive 12i. And last 2 multiplication will be plus 16i squared, which you end up canceling the middle term. And you do negative 9 And don't forget, when you have I square, this is equals to -1. So it means you're going to have -16 become -16. So that gives you -25. So here you will have -25 added into 28, so it'll be 3. 3 times 3 minus 4i is 9, minus 12i. And -18 plus 9 is -9 minus 12i. And we will do another multiplications. 3 minus 4i times -9 minus 12i. 3 times -9, -27. Then outer multiplication, -36i. Inner is positive. 4 times 9 is another 36. And -4 times -12 is positive 48i square. Middle term cancel out. You get -27 minus 48. What you end up getting, -75. And you kind already know that's what you need to get it. Why? Because this is your solution. 3 minus 4i is your solutions. Means you're going to get 0 here. In order to get 0, this have to be -75, right? And it matched. So you know this is 75, right? So you know you got it right. We reduce from 4th degree. Oh, wait. 4th degree. We reduce from 4th degree to the 3rd. Now we need to make it quadratic. Because we know any types of quadratic we should be able to factor or solve using different method. So let's do another synthetic divisions with 3 plus 4i this time. Bring down 1, multiply, you get 3 plus 4i. And it cancels out whole thing and you get 0. And 0 times whatever it will be 0, added will be 3. 3 times 3 plus 4i is 9 plus 12i, which will be 0. So this 2 becoming 0, you can already know about it, right? And you just need to know what types of quadratic you're going to get once you factor this 2 out. So here, this is going to be your quadratic. Because the middle term is 0, you're going to end up getting 1x squared plus 3, right? Because this is 0, your x is 0. And in order to find the solutions, 2 more solutions, you're going to solve this equals to 0. You're going to isolate x by subtracting both sides by 3 and use the square root property to get rid of square. And we know this is the same as plus minus square I square root of 3. And there is 2 other solutions. So if I wanted to list all the solutions here, you have plus minus I square root of 3 and 3 plus minus 4i. 4 solution right here. Next example we're going to look at is finding polynomial function with given conditions, right? We did similar one before. The difference between this one and the problem before, we have different condition given. So let's look at n equals to 3 means we're going to look at the cubic functions, third degree functions, right? And you have 1 solutions, 2 solutions. With this solution given, we know that also negative 5i will be the solutions. Because remember from the previous problem, I say whenever you have I solution, opposite sign will be also the solution, part of the solutions you have. So 5i are 0 means negative 5i will be also 0 of the functions. And because you have f negative 1 equals to negative 104, so the new condition, because this condition, you're going to have constant throughout the functions. So we need to find that constant first. So let's see. So far with this information, I can say, let me reuse the flag. I can say my function f of x is equals to factor of x. Well, you're going to start with constant. Remember, you're going to have a constant. And then the first factor is 1. Well, first solution is 1, so your factor will be x minus 1. Second solution is 5i, so second factor will be x minus 5i. For negative 5i, your factor is going to be x plus 5i. And this is how your function is going to be look like. But with the given condition of f of negative 1 is equals to negative 104, we need to know what that a is going to be, right? So we're going to do f of negative 1 on this equation or functions. You're going to replace x with negative 1 and see what a you're going to get, right? So it will be negative 1 here minus 5i and negative 1 plus 5i. That should get negative 104. And you get that's negative 2. And this is going to be negative 1. You need to do foiling. So you're going to end up getting positive 1. And we know that because it's the opposite, you're going to cancel out the middle term. So when you multiply last two terms, you're going to get negative 25i squared equals to negative 104. And that is same as having 1 plus 25. And that's a times negative 2 times 26 equal to negative 104. You multiply negative 2 with 26, you get negative 52. And when you isolate a, you need to divide both sides by negative 52. So you get positive 2 for A. So once you have positive 2 for A, we can replace back. So your function f of x had to have 2 times x minus 1 times x minus 5i and x plus 5i. Or if you wanted to go a little further, you could even say 2 times x minus 1 times you foil this, you get x squared plus 25. If you go standard form of that functions, you're going to foil this 2 and distribute 2. You end up getting 2x cubed minus 2x squared plus 50 x minus 50 as your f of x. And you can pick any of this format. Depends on how they're asking, right? If they want the factor form, this is going to be factor form. If they want the standard form, this is going to be standard form of the functions that satisfy this given conditions. Let's try another one. So this one B, you have n degree equals to 4. It means you need to have 4 factor, but how many factor or solution is given? You have 2, negative 2, 2, and I. You have 3 given. But because I is given, you know also negative I will be solutions even it's not given, right? And then when f is 3, it will be equals to negative 150. So let's see if we can build a function with constant a with all this solution given. First solution was x negative 2, so it will be x plus 2. Second is 2. That gives you x minus 2. Third is I, so that is x minus I. And fourth is negative I. It gives you plus I. So that will be the functions that we're looking for with this given conditions. We need to find A. How do we find this constant for the equations? Well, using f of 3 equals to negative 150. So let's see. We will try f of 3 to find your A. When you're rewriting all this, you know that x plus 2 times x minus 2. When you FOIL this is going to give you x squared minus 4, right? And then when you FOIL this 2, you will get x, cancel out the middle term, it will be negative I squared become plus 1. Equals to negative 150. So when we replace x with 3, I forgot the square right there. We have 3 squared is 9 minus 4 is 5. 9 plus 1 is 10. So you have 8 times 50. So your A become 150 minus 50 with negative, so will be negative 3. So once you know negative 3 is your constant, then you will say f of x equals to negative 3 times, we can reduce, we can write it a simpler form with x squared minus 4 and x squared plus 1 as the factor form, right? So if they want the solution in factor form, that's factor form. If you wanted to multiply this out, you get negative 3x to the 4th plus 9x squared plus 12 as the standard form.